Hello there. So this is that conditional probability problem from another video where I showed how I would approach it. But there was another user named Alkalannar. I'm sorry if I'm mispronouncing that, but they um, had a slick way of approaching this problem that I really liked. And looking at it, since they use slightly different notation, it seems a little confusing at first. But I wanted to start by showing what they meant and then showing why it's true. Okay. So that top part here, they say that if you write capital A, capital B, that means A and B happening. Okay. Uh, so there, I got the wrong thing there. I apologize. Give me just a second to adjust. All right, so they say that uh, the the probability of A and B happening is going to be written like this. Capital A lowercase b is the probability of A happening and B not happening. And that you write it as AB. Then lowercase a, capital B is the probability of A not happening and B happening. And then both being lowercase is the probability of A not happening and B not happening. All right, so let's see why these things are true, given that this top part here is the probability of A, this is the probability of A or B, and this is the probability of A given that B has already occurred. So we're going to look at this, and then this is the probability that something will happen. All right, so looking at this, I'm going to go through and highlight whenever I'm talking about a specific part so you can see what it looks like. So first, we've got the first one. This is the probability that A happens. All right, so the probability of A is the probability of A and B happening. That's this middle part in here, and we'll give that a lovely shade of purple. So this part in here is A and B. And if you add to that the probability of A happening and B not happening, that's this part over here. And if you notice, after you shade in all of this, you've just shaded in the whole circle for event A, which means that if you add those two pieces together, then you do indeed get the probability of A. Okay. Next part, the probability of A and B happening. That's that middle part again. I'll color it purple again. Okay, plus the probability of A happening and B not happening, which once again, this is going to look pretty similar. By the way, when you solve these, this is part that you can substitute in for. You can substitute that first value in for this part right here. All right, and then we add the probability of B happening and A not happening, all right, which is this area over here. All right, and if you notice, I have shaded both circles in their entirety, and I didn't overlap. That means that I have just shaded in the probability of A happening or B happening. And that's where we get that 3/4 from. All right. Next, this one is our conditional probability. We've got A and B happening, which is that middle part again. This time, though, we're dividing, so it's not going to look exactly the same. We're dividing by the probability of, or A happening and B happening, which is the middle part, plus A not happening and B happening. So this section over here. So what we just divided by was the probability, well, we just divided was the probability of A and B happening. And we divided that by these two things together, which is the probability of B happening. Which, if you remember, this right here is Bayes' theorem that the original poster talked about. And so that part gives us 1/3. And then the last one, let me clear the table real quick. The last one there is the probability of A and B, which is once again that middle part. Oh, wrong kind of pen. It's once again that middle part. The probability of A happening and B not happening, which is this area over here. The probability of B happening and A not happening, which is this area over here. And then the probability that neither one of them happens, which is everything else. All this stuff out here. All right. And if you add all that up, you get 1. Because the probability that something does or does not happen is 1. Okay. Anyway, I just thought that that was a really slick way of approaching that problem. Kudos to Alkalannar for showing that, and I hope that helped. Have a good one.